Welcome to the final exam, question number 49, and it gives us a steel beam spans 30 feet, so L equals 30 feet. It supports a load of 12,000 PLF, or 1,200 PLF, sorry. There we go. The beam's compression flange is laterally braced at its ends and mid-span, so it's LU, let's call it, for unbraced equals 15 foot. Says using ASTM A36 steel, we know that Fy equals 36 KSI. Neglecting the weight of the beam, what is the most economical beam which may be used? And just seeing that this information, you know, when it's not fully supported and you have different issues with buckling and whatnot, you just want to use the charts. So what we'll need to do is we need to make sure when we go in to this chart that we want to make sure that its unbraced length is 15 foot and that it's, I think, well, actually we go in there with the moment. So let's figure out what the moment is real quick. Let's look at the chart actually and see what we need. How about that, in case you don't know? Alright, so you go in there with go to page 69 in your study guide, which they will provide this for you. And it says at the bottom, it says unbraced length. So you know that's what we're wanting to use. And we want to go up to the top right, and it says Fy equals 36. Don't worry about the CB equals 1 for right now. Later on, if you get a little bit further in structural analysis, you can worry about that. But for right now, you assume that CB equals 1. And we have a uniform dead load. So we know for a uniform dead load, in simple span, we have WL squared over 8 equals what? 1,200 PLF times. Now remember, we don't want to use this. We want to use L because it's only braced at 15 foot. Its length is still, its span is still 30 foot. So you don't want to get confused on that. If you have to draw a picture, you know, you can draw a picture to say, okay, I have this beam. It's a steel beam. It's got 2 supports. It's got 2 flanges. And then it also has this bracing. So you could just put a stiffener in there to make it look like it has a diaphragm or something to help brace it. So there you go. That will do it. And looking from overhead, it could look like this. Here's your beam. And once again, this is a terrible sketch. And then you have this diaphragm right here. So these are stiffeners that I showed up there, and then this diaphragm will be bolted on or whatnot onto this stiffener. Now once again, this is not the perfect drawing in the world. So let's say this stiffener is a wide flange beam. I'll put this in dashed. That's the flange. This is the flange. I'm dashing the web. And then the web hooks onto that other stiffener right there. And therefore it's braced. Alright. So going back to the problem. Let me get out my calculator here. WL squared divided by 8. So you have 12,000. 1,200. Second time I've done that. Squared divided by 8 equals, once again my calculator is missing a line, but I believe it's 135,000, and that's going to be in foot pounds. So 135 foot kips. Alright, so we want to go in there with 135 foot kips, because if you looked on the left, it said allowable moment. So we know that, hey, shoot, we need moment, and we now have moment. Alright, so let's go into that with 135 and then go over or you could start at 15 and go up. 15, let's see where 15 is. 15 is right there, and obviously you can't see what I'm doing. Hopefully you went down at 15 or started at 35. Whatever's easier for you, and sometimes it's a little difficult to find these. So I'm now at 135 and 15, and what you now do is you just go to the right, and I see the first non-dashed line you come to is your answer. W14 by 53 is the first. W14 by 53 is the first beam I came to. And if you go to your answers, you'll see that A is W14 by 53. So there you go. That was pretty simple.